So how do I know which is the better way to do a problem? Here we are taking the region bounded by y equals x minus x squared and y equals 0. We're rotating around the line x equals 2. So my geometry is a little bit more complicated, but I can still do this. I just have to draw the picture and make sure that I understand the geometry that I'm being asked for. So here is my picture. On the left is my parabola, y equals x minus x squared. It hits the x-axis in two different places. Those will be 0 and 1. And I'm going to take this blue region here and rotate it around. So I'm expecting some kind of weird Jello mold. Again, that's a pretty common shape for this kind of solid. Notice, however, that my radius is going to be defined from the x-coordinate x equals 2. I am not spinning about the y-axis. I'm spinning about x equals 2. So this will change the geometry slightly. The question in my mind is, do I want to slice along the x-axis? If I do a slice in the x-axis, I'll get a cylinder. Just like here, I'll have some shell I need to calculate. If I slice in the y-axis, I will get washers, which I can do like from last time, just a disc with a hole in it. The problem I see with doing the washer method, if I was going to slice in the y coordinate, is that my two different radii are both coming from the same function, right? If I'm slicing in y, my large radius is defined by the left side of this parabola. My small radius is defined by the right side. And at this moment in time, I just don't want to do the algebra to figure out those two different coordinates. I'll have a much easier time using the method of shells. So again, shell formula requires three different things: thickness, circumference, and height. My thickness is just going to be my differential, my dx, very simple. My height is going to be, well, it's just the value of my function, the difference between x minus x squared and 0. The tricky part about this one is going to be figuring out the circumference, bearing in mind that my radius is now going to be the distance from x-coordinate 2 to whatever x-coordinate I actually want. We'll call that 2 minus x. 2 minus x is the distance between 2 and x, so long as x is to the left of coordinate 2. Let's put that in the integral formula. Slightly different now. But what do I have here? I have my circumference. I have my height. I have my thickness. Again, I'll pull out my 2 times pi. I will FOIL my two different polynomial factors together. That leaves me with, looks like a degree 4 this time around, but degree of a polynomial never stopped me from finding an antiderivative. I evaluate at 0 and 1. Fundamental theorem of calculus tells me this volume is equal to pi divided by 2.